Welcome everyone. This is part 3 of our little mini-series on Introduction to Stress Analysis using Autodesk Inventor for the SE 101 course. In the first part of this little series, we talked about kind of the basic background behind stress analysis and finite element analysis and why we need to use it and why it's useful. And the second part, we looked at an assembly and talked about some strategies for testing which part we should test, how we should test, and things like that. So today we're going to talk about doing just a really quick case study using a very simple part. Remember when we talked about in the first part, there's two ways we can apply a force to our material. And the first one is just applying a standard force at a point. The second one is going to be applying a pressure, which is a force distributed over an area. The first case study that we're going to do in Inventor, which is going to be this geometry. It's just going to be a basic beam with a chamfer on the end, fixed at one end, and with a bunch of just randomly placed, randomly sized holes. We're going to apply a force to this one and look at how the material reacts when we apply a force to it. So first thing we want to do is create our part, obviously, and then let's go to the stress analysis toolbar. We can either get to it from the 3D model, or we can get to it through environments. I'm just going to click on it here. We want to create study. We don't need to change anything in this window. This should be fine. If we want to do something special, we can later, but I'm not going to worry about it at this point. We want to assign a material. In this case, it's just generic. Let's override. Let's pick a material. A good material, I think, will be nylon for this. Let's find nylon in the list. So nylon. Let's do nylon 6.6. That should be good. Okay, so that's going to be the material that we apply to it. Now we need to do two things. We need to apply constraints at some point in here, and we need to apply force. First thing we do is do constraints. We talked about it being fixed at this end, so we'll just go here, pick a fixed constraint, fix it here, click apply. Okay, what this does is it just fixes all 6 degrees of freedom, but only on this face. So this would simulate something like if this was stuck in a concrete wall or whatever, it would be it'd be fixed at this end. The rest of it's free to deform and move. This is a really simple case, so we're only going to put one force on it, on this right here. So let's go here to force, up here in loads, force. We'll put a force of 500 newtons on this face. Apply. Okay. That should be good. Now we have our two main things that we must have. We have a constraint and we have a force. Now let's go here to mesh. What we're doing with mesh is we're discretizing it so that we're basically dividing it up into a bunch of smaller little regions that are easier to analyze. So let's mesh this. That's kind of a rough mesh, but it should work for this. It calculated it, so it should be okay. Now let's go to simulate. Run. This is going to run pretty fast, and there we go. Now we have our finite element analysis, and what is one of the things? The first thing we notice is there's a red part right here. If we look at the color bar, the red shows that this is where the most stress is going to be. So if we're trying to design this, then the most stress is going to be right down here, and this is most likely going to be the place where it fails. So when you're doing your projects and you're applying forces and doing finite element analysis on your parts, then look for things like this, because this is where you want to talk about potential product improvements and things like that. So this is just a very, very brief case study doing this with just a force. In part 4 of this series, we're going to do it with a more complicated problem with a pressure. And I'm not going to since I'm limited to 5 minutes per video, then I'm not going to go ahead and set up everything again, but we'll just talk about the results, more of that one, when I set it up quickly. Thank you for your time, and see you in the next video.